All right, let's get you started on this assignment. So this first part should be a review, converting degree measure to radians and radian measure to degree. And so let's do a couple of each of these so you can remember how to do it. To convert from degree to radians, we multiply by pi over 180. And then our answer will just have a pi in it. And so then that also tells us that it has been converted to radians. So when we do that, we're not going to change it to a decimal. We are just going to reduce it. So you get this. Okay, so you get 230 over 80. And you could write that out, but I'm just going to go ahead and reduce. So I notice they both have a 0 that will reduce off. And so our answer is just going to be 23 pi over 18. And you could write it 23 over 18 pi, but we usually just leave it all together as one fraction. So that's how you're going to do this first section right here, multiply by pi over 180. To convert from radian to degrees, we're going to do the opposite. We're going to multiply by 180 over pi. And if you notice, these radian degrees already have a pi in them. And so dividing by the pi cancels the pi out. And then we have this value here that can reduce. You could go ahead and multiply 23 times 180 and then divide by 12, but I like to reduce it first. So I would look at it and go, let's see, how many times will 12 divide into 180? Let's see if it divides evenly. It does. So 12 goes into 180 15 times. And then you have 23 times 15, which is 345. And be sure that when you write the answer, it's 345 degrees. You put the little degree sign. And that's how you're going to do those right there. The next section is finding the exact value of each trigonometric function. And when it says that, again, we're not going to use a calculator. We're not going to find decimal answers. We are going to first look at the unit circle. So look at tangent of 5 pi over 6. So I'm going to flip over to the unit circle and look there. And tangent of 5 pi over 6, there's 5 pi over 6. The coordinates are negative square root of 3 over 2, 1/2. So then that's the x value, that's the y value. And if you remember, in the last unit, we did tangent to be the sine or the y value over the x value. So that's what I'm going to write. So let me go back to my chart here. So I'm going to write 1/2 over the negative square roots of 3 over 2. Now, if you remember how to divide a fraction by a fraction, we take the bottom one and we take the reciprocal of it. So that would be negative 2 over the square roots of 3. And we multiply. Now, before we multiply, I'm going to reduce. So the 2 cancels out the 2, and I end up with just this negative 1 over square roots of 3. But if you remember, we have to rationalize that denominator, multiply top and bottom by the square root of 3, and we get negative square roots of 3 over 3. Okay, let's do another one. So let's look at the sine of pi over 3. So I'm going to refer back to my unit circle. Sine of pi over 3. Pi over 3 is right there. And the sine is the y value. So I'm going to come back here. And the sine is the y value. So it is just square root of 3 over 2. Okay, now sine is typically opposite over hypotenuse, but where the hypotenuse is always just 1 in a unit circle, then we don't have to worry about that there. It's just the y value. All right, let's look at number 7, the tangent of pi over 2. So I'm going to look back at my unit circle. Pi over 2 is right here, right up there on the axis, and the tangent is the opposite over the adjacent. So it'd be the y value over the x, which is 1 divided by 0. And 1 divided by 0 gives us an undefined answer. So number 9 is undefined. Okay, hopefully that's enough to get you going on those. The next ones are finding areas of sectors. So we're going to use our area formula. And because it's given in degrees, I'm going to use the formula that uses degrees. So that's 0 over 360 times pi r squared. So it's basically the piece or the portion of the circle. So whatever the angle of the circle is, times pi r squared, which is the area of the circle. So then we'd put 270 over 360 and pi times 13 squared. And then you just plug that in a calculator and find that value. Oh, no, actually, we're just going to reduce it. So we have 13 squared times 270 is 45,630. Sorry, my handwriting is not so great here. Over 360 pi. And then that reduces to 5077 over 4 pi. Number 24, the formula we're going to use for that, since it does give you the value in radians, we're going to use the radian formula. These formulas would be really good to have in your notes. So it's 1/2 of r squared theta. So then you just take 1/2 of 6 squared times pi over 3. And you end up with 6 pi. And again, your answer is just going to be with a pi because it's in radians. And the last thing you have to know how to do is find the length of each arc. So the arc length, when it's given in radians, is just theta times r. So that means we just have 5 times pi over 4, which then you could leave just 5 pi over 4. I think on the answer key I put it in decimals. Either way works. So 5 pi over 4, or about 3.9 inches. When you're given degrees, then the arc length formula is 2 pi r times that portion, so the degree over 360. Which, when you multiply 135 times 2 times 5, you get 15/4 pi. Or if you change that to a decimal, it's 11.8 feet. Okay, hopefully that's enough to get you going. The answer key will be posted so you can check your answers. Have fun.